Okay, hello folks. So welcome to Cloud Native Life. So where we dive deep into the code behind Cloud Native. So I'm your host Sharier, almost like a Mithil. So you can call me Mithil Sharier as a whole. So I'm a CSF ambassador. So I'll be host tonight. So every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. So they will build things, they will break things, and they will answer your questions. So in today's session, I'm stoked to introduce Nick, who will be presenting on Label Up Your Database Security. Okay, so this is an official live stream of the CNCF and as such is subject to the CNCF Code of Conduct. So please do not add anything to the chat or question that would be in violation of the Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. So with that, I will add Nick to the stream. So yeah, hello Nick, how are you?
Hi, I'm very good. Very good. Very happy to be there. So, yeah,
Yeah.
hopefully it's going to be a fun one today.
hmm Yeah, awesome. So it would be awesome if you can introduce yourself. So okay, uh, let's do it.
Okay. Can you see my screen? Yeah, all good?
Yes.
Okay, I'll just do some, yeah, introduce the topic, introduce myself, couple of slides, and
hmm
then we can go directly into the code, the application, and hopefully have some fun. All right.
Yeah, let's go.
Okay, let's go. So today we're going to focus on level up your database security and how we can automate access control and just-in-time credential with authorized Kubernetes operators. I'm going to introduce, what we do as at Otterize in terms of open source and the technologies. But first, yeah, the topic for today is really from the developer perspective and how we can remove the friction from the moment a developer needs a database. So here we're not talking about, the process of deploying the database, but more the process of accessing the database with the right credential, the appropriate credential, meaning least privilege, and how we can enforce this least privilege principle in a declarative manner without involving any sort of Jira ticketing or anything that can slow down the development lifecycle that involves security, because we know that security tends to kind of slow down development lifecycle. So yeah, it's going to be how we can automate all this portion. So yeah, my name is Nick. Nick Vermondy. I'm the head of developer relation at Otterize. I've been working with Kubernetes probably 8 years now. I didn't update. I always say like 7 years from last year, I think. Now it should be around 8 years working on Kubernetes. In different capacities. I've been working in product management, in engineering, technical marketing as well, and more recently, for the last couple of years, more developer relations. So on CNI, CSI, Edge, security. I think pretty much everything around Kubernetes. I love to code as well, and so today is going to be a fun game, hopefully a murder mystery game that we will have to solve using a database, PostgreSQL today. Fun fact about me, I'm an avid distance runner. I'm probably running about 100 kilometers, something like that per week. So I would say if you want to contact me, of course, you can use LinkedIn, but Strava is probably where I spend the most time these days. All right, let's get started. So removing friction for developer is really our key, let's say, mantra at Authorize. So what we do as open source projects. So Authorize is both the name of the company and the name of the solution, or the umbrella on top of the solutions that we provide. It's fully open source. So we simplify and automate access policies for workloads in Kubernetes in a declarative fashion by encapsulating developer intents into a custom resource that we call client intent. And a client intent can basically be used for many different things that we're going to see in a minute. And this unified frameworks allows us to automate a lot of security. So it can be network policies, Istio authorization policies, can be a cloud IAM. We can also automate at application level, access things like Kafka access list, and we can also automate database access, and this is the topic for today. And this kind of unifying framework, we call it IBAC. So that's the name of the solution. It's intent-based access control, where you simply express your intent as a developer in your security requirement. Like, I want to access this database with that access, with that typical, with that particular permissions. I want to talk to that service that is residing in Kubernetes. I want to talk to like this RDS database, this S3 bucket, this kind of things in a very high level fashion, and then we'll automate the lower level security mechanism using operators, right? So this is called IBAC. And so for today, we're gonna use a game with a lot of different microservices to do multiple things. So you can see at the bottom here, we have a Postgres database. And the game, as I said, is a murder mystery where you have to solve a particular crime. So we have multiple service. We have the game service. So the player connects via a WebSocket to the game service. So it's all text-based, like old school text-based, like when I was a kid, we used to have those games. I'm 44, so that was that was a long time ago. So the game service itself is talking to multiple other service. So the case service to generate the case and the different clues. We have the player service that's going to ask you for a name. We have the evidence service where you can examine particular evidence and locations. We have interrogation service where you can get a list of suspects and ask them questions. And we have the deduction service where you can basically propose your solution to solve the crime. I mean, sometimes I also do another demo, which is like how we can get to a developer workflow. So we can also monitor the changes between what the developer, I mentioned client intent, which is the way to represent the, let's say, the desire of the developer, the intent of the developer in terms of what they need. But there are two ways to use that. Either you can do it manually, or you can also we can also leverage eBPF to monitor, to capture real-time traffic, and then we can craft policies. Like, for example, if we see that the game service is talking to the player service, we're going to see in a minute, then we can generate the client intent for you. And if we detect new intent as you place the client intent on a GitHub repository, excuse me, then we can automatically raise pull requests on that repository, and then you can use, you can just merge the pull request and use any sort of GitOps workflow or software like Flux or Argo CD to apply the security changes at the same time as your code. So yeah, it's kind of shifting security left closer to the closer in the development lifecycle, so that when you deploy to staging or production, there's no delay between the moment you deploy the application and the moment you have a kind of a zero trust situation here. And the criminal lab service is exactly that. We have a version 2. We detect the different, the new intent. So basically the criminal lab service talking to Postgres, and then we can merge the pull request. We're not gonna see this today because I really want to focus on what's happening in terms of credentials. So not focusing on network security really, even though we'll see some of it, but more on the SQL, credentials and how it works. And so an example of client intents of, like IBAC. So this is, for example, here, we focus on the player service talking to the database. So there are a couple of things we want to specify, or things we, as I said, can be manual, or we can rely on eBPF to generate this intent. So we can detect the database, calls to the database, and what permissions this requires, and we can detect calls from monitoring the network. So here, the client intent, as I said, is a custom resource in Kubernetes, and is really the center, of what we're going to automate after that. So Kubernetes is our center of gravity as well, but the database itself today is going to be deployed in Kubernetes, but it doesn't have to, right? The calling service has to sit within Kubernetes, right? But the destination database doesn't have to be, a specific container. It can be a virtual machine, a physical server, can be located in the cloud. It doesn't really matter because we will connect to that database to create the credentials. So if we take a closer look here, what we have. So we specified a particular service. So the player service, this is our client. So client intent is client focused. So again, the idea is in the same way an Android or just a mobile developer specify a list of device capabilities they need to make their application work. So for example, if you need to access a device, camera, Wi-Fi, this kind of capability, you just specify it into a file, right? And then when the user install the application, they just have to basically answer and agree to share the camera or to give the application access to the camera and the different capabilities. Here's the same kind of principle. We just want to using a declarative intent. As a developer, I want to access these services, or I need this specific requirement. So for example, here I need to call the database on the network. So I need to get access to my database service in Kubernetes. So the assumption here, the first line, name DB, without any other parameter, would assume that you want to access to a Kubernetes service when you have a very simple line. So if you have a CNI that support network policies, then this is gonna create and automate network policy, translate or convert, if you want, the client intents high level intent, the client intent high level mechanism into a lower level security mechanism. In that case, network policies can be Istio as well, service mesh, different network layer. Then the second one, which is what we are really interested in today, is type database. So name of the DB, that would be DB. It just happens like, this is the same component, but one would be for the network, one is the actual database. So type database. The database resource, we can go by table as well. We can go as granular as table if we want. But here I didn't specify any table, so it's considered for the every table in the database. So we have the database name, that's the name of the database instance. ODA for Otter Detective Agency, right? Otterize, Otter, that's in the name. So this is our game, our database, and the operations I need from the player service talking to Postgres is insert, update, and select. As a result of that, this time we're going to translate the high-level client intent into credentials. So the first thing that we're going to do is connect to the database, create a particular user credential, so username, password, as well as the correspond and attach the corresponding SQL grants permissions. That's the first thing we're going to do. The second thing we're going to do is also create a Kubernetes secret and wrap this credential, username, password into that secret. So that secret can then be mounted by the calling application to connect to the database. And when you run your code, then it will just use those particular credentials. We can also rotate those credentials, and this is something that is configurable when you deploy the Otterize solution. So meaning that now you don't, as a developer, you don't have to ask anyone, like you don't have to open a Jira ticket to the platform team to create a particular username, password. You don't have to kind of second guess what permissions you need. And probably most of the time, as it's a bad practice, but in reality, this is probably what we all do as developers. We just use the admin credentials to connect the database, which may be fine in development stage, but not necessarily once you go to staging and production. You should not do that, right? So yeah, it's basically removing any friction, because now this client intent, the goal is to collocate it with your code, and as you deploy your code into and package it, you just throw it into your deployment pipeline, your CI pipeline or CD pipeline, then this client intents get deployed at the same time as the application. And as a result, because this is a CRD, then Kubernetes via the authorized operators will reconcile the client intent with the current configuration in the cluster and do all that nice automation. All right, so I think that is basically it for the theory. So now I will just switch to the demo. So here on the right, I've got my console where this is my Kubernetes cluster. The first thing I need to do, so the application is not deployed yet. What I have deployed though is I have a CNI that supports network policies. This is Minikube on my local on my laptop. Then I have authorized container that are already deployed, but I will redeploy it. It's not currently connected to authorized cloud. So Otterize is essentially two parts. There is one part that is running into the cluster, and by itself, it can be sufficient to generate policies and apply, client intent, reconcile client intent, all that nice stuff. But you can connect to the cloud to do further integration, like if you want to manage things like integration with AWS, if you want better visibility, if you want nice graphs, all of that. So yeah, again, it's open source. We don't ask for anything specific on the cloud part. So yeah, you can use it if you want to test it. Yeah, it's also this lab is available from our docs in a sandbox as an instruct lab. I will have a reference in the end if you want to test it. So the first thing I want to do is connect my cluster to Authorize Cloud. So for that, I need to create a new integration. So integration would be a Kubernetes integration. Next, let's call it ODA. Let's use my test environment, create, super easy. Then I just have here a Helm chart command line that specify. I mean, of course, you don't need to connect to Authorize Cloud to use the Helm chart, but it's going to give you like a specific client ID and client secrets so that you can connect back to hook it back into the cloud. And for the moment, we're going to keep enforcement off. So enforcement off means that Authorize is going to be used in learning mode for network policies, meaning that we're going to the client intents are not going to be translated into network policy, but we can enable it later, right? It can still generate and detect traffic and capture traffic,
Hmm.
but as a result, we don't generate the policies. So I can just now copy this line. Next, done, and I'll just paste it. And as a result, I should see here the different container that will be restarted or redeployed. So the different components we have the credentials operator. Its role is really, as it names stands for, is to create credentials like the secrets for the databases, all these kind of things. The intents operator is another operator whose role is to reconcile the client intents with the cluster and translate this higher level resource, so the client intent, into lower level mechanism like network policies, authorization policy, and the database credentials. Then we have the network mapper. So the role of the network mapper is to communicate with the sniffer and report the findings. So the sniffer is essentially monitoring. It's a daemon set and it's monitoring what's happening in the cluster. Reply, TCP, SYN-ACK, all this kind of network mechanism that will give us clues in terms of the application pattern. So now also I have Argo CD. I'm using the app of app pattern. So you guys, if you guys don't know what the app of app patterns is in Argo, is just basically a pattern that allows you to deploy multiple application components with a single application resource. So here I'm in my repo, and it should be the ODA deployer. So as soon as I do that, I should see all my application here that will be deployed. All right. So this is the one that would be useful. Uh, so you can see multiple containers, the different services. So the DB init job that will succeed in the next one is the one populating the game case, right? So all the different clues and the story. So our DB is already deployed. Our DB is being filled with all the information. So now we should be good to go, and I should start maybe seeing some of the application here on the left. Maybe it will come in a bit at some point. But let's first generate some traffic. So to do that, yeah, let's port forward the game service. I'm going to set a new game. So I'm just calling the start new game on the application here. And we're going to be using WSCat. So remember, we need to use a WebSocket to connect to the game. Okay, so here we are connected. And just to show you the code a little bit before that. So the code, typically, I'm just going to show you the part that is interesting for today. How, as a developer, you know what kind of permissions you need. So as I said, there's two ways, right? Either we can monitor using eBPF, or you can specify manually, right? So here for every, for the create case, here I need to insert into the database. For getting the case, I need to select. So you just kind of, going through your code and just listing what permissions you need. This is how it should be done,
Mhm.
right? So kind of documenting your application. But as developer, we're kind of lazy most of the time, and we don't do that, right? So
Yeah.
yeah, as I said, with eBPF we can do it for you, but today we're gonna do it. We're gonna do it manually. So enter your name. So my name is Nick. So greetings, Detective Nick. Please press enter to get started. So this is our case for today. So you've been assigned the case of the stolen golden fish. The Otter Museum's prized possession, a solid gold statue of an otter holding a fish, has been stolen overnight. The statue, valued at $1 million, quite expensive, was the centerpiece of the museum's aquatic treasures exhibit. The theft
Mhm.
occurred despite the museum's state-of-the-art security system. Your task is to investigate the crime scene, gather evidence, and interrogate suspect to solve this fishy case. So okay,
Mhm.
so now it's the base of the game. So we need, every type of action relates to a database specific, like action and code. So we can just type, go through locations. So we have multiple locations. Let's use, for example, I don't know, the parking lots. So we can type examine parking lots. So this is going to generate traffic for this. And we can then investigate tire tracks. So we can have clues. So fresh tires, tracks leading away from the staff parking area, indicating a hasty departure. So there's a clue. It's leading from the staff parking area, right? That's the first clue, the staff parking area. So let's go back.
Mhm.
Now we can have maybe some suspects. Who's the list of the suspects? We have Dr. Olivia Whiskers, the curator of the museum, knowing for her extensive knowledge of aquatic artifacts. We have Finn Waters, the newly hired night guard, started working at the museum. And Marina Shells, a wealthy collector who has previously expressed interest in acquiring the statue. So
Hmm.
then let's interrogate Dr. I'll make it short because obviously I know who is the culprit.
So-
Okay, so Dr. Olivia Whiskers, where were you on the night of the thefts? Do you know anyone who might want to steal the statue? Have you noticed anything unusual at the museum lately? Let's ask three. So we are again using another part of the database. Have you noticed anything unusual? And she's saying, now that you mention it, our night guard Finn has been asking a lot of questions about the statue's value. Right. So of course now we have two clues. One, the tire tracks leaving the staff parking, and then potentially the guard who is part of the staff once did the statue.
Mhm.
Right? Obviously, the culprit is him. So we can type solve. Again, what's the name? Go there. Oh, so that's Finn Waters, right? Solve. Okay. What do you think? Finn
Hmm.
Waters. That's him. Congratulations. Yeah, no, I don't want to play anymore. Thanks for playing. So we have
Okay.
generated enough traffic. So now, normally in the access graph, let's monitor, let's filter the cluster. I've got quite a few cluster there. So I want to filter by cluster. I want my, where is it? Oops, ODA cluster. This is it. Okay, I want to filter by namespace as well. Namespace is ODA. All right, so you can see here, I want to first assume default deny in network policies. This is, when you run kind of in learning mode, you want to assume default deny to see what would be blocked if you were to assume default deny. So you can see here, let's not pay attention to the intents operator and the credentials operator. This is part of Otterize system, and they are both talking to the database to essentially generate, to connect to the database to create credentials and all that stuff. So it's normal that it is green. It's network policies are there by default. It's red, meaning that we don't have client intent and therefore no network policy to connect to the database. So first we need to generate the client intent. Once we have the client intent, it will turn green. And then we need also to get the database integration. So the first thing we need to do, so there's two ways actually to get the client intent. You can do something as easy as you can go there and maybe click on the game service. Look, you click here and you can see here seen in discovered traffic, but not declare in client intent, of course, because we don't have created any client intent yet. So if I was to apply this, then with enforcement enable, it will create the network policy, right? The only thing I did is generate network traffic, right? And because we are monitoring the traffic, this is what we have observed from the real-time traffic, and it's basically kept forever, up to 2 weeks, but we will keep history, right? So even something happened like now, and in 2 weeks' time, you just deploy the policies and you just click here, it will still appear. Like we won't omit traffic we've seen in the past because we want to stay compatible with your process. If you have a batch that runs once a quarter, we need to be able to capture this. And once it's been captured, it needs to stay there. The network policy needs to stay there forever, right? Because obviously the batch is going to happen again. And then the second solution, you can also use our CLI tool to do that. So again, as I said, you don't necessarily need to connect to Authorize Cloud, but yeah, you can just use Authorize mapper command. So just type authorize mapper export -n and the name of the namespace, and you will see the entire list of all the client intent. Again, the client intent is just what we need, is what we are working with. We don't work with network policies or the database credentials or anything. We work with client intents, and then Kubernetes reconcile. So here it's exactly what we will see here from the database, all the content, except in the CLI, you don't see the egress content. So here we also detect what is going outside of the cluster, like any call that is made to an external API. If you want to enable egress network policies, this is how you can do it as well, right? So this is very important because in Kubernetes, egress network policy can be very difficult to manage. So if you want to enable that because the security teams has required it, it's just a walk in the park. It's there by default. And we can also translate DNS to network policies like to IP because, of course, if you guys know network policies in Kubernetes, you cannot specify your DNS name. It has to be IP addresses, but we can convert that. So it's pretty nice. So now the only thing I need to do, so first let's move to the cluster to verify I don't have any client intent. It's just the basic one from the client operator, intents operator, and this is why it's green, right? And currently, I just have a couple of network policies. It's the default one, right? It's the one that comes with Argo, and as you deploy Otterize system, the Otterize solution. So it's not part. It's not been generated because of the client intent. Because remember, we don't have enforcement enabled. So, but what you can do though is Authorize mapper exports, and then you can pipe it directly to kubectl apply -f, and then we will have the client intent produced for you, right? So they are there in the cluster. So again, we can check the game service. Game service, we'll see what we've seen before, right? Exactly the same thing. So we see that the game service is calling all the other service, right? Because I've generated the traffic, went through the game, so I've called pretty much every single service, right? So now if I enable enforcement, then we will generate network policies. And now I know that my application is fine because now everything is green, which means that if I were to apply on top of that a default deny on a per namespace basis, if you like, then the application would work, right? Because I've got the required client intent. But now let's talk about the database. So the database, I have the client intent here. So if I just apply, that's client intent, that's the Postgres SQL Server config here. Let's apply this. So this is another resource that we manage, PostgreSQL config. Is just to declare a couple of information on your database. So the address, how you can reach that particular service. So here it's a Kubernetes service, so it has this format. So name of the service, name of the namespace .svc.cluster.local, and the port. And then in which secret you are storing the admin credential, or not the admin. Actually, we publish a list of permissions that we need, but this credential will give Authorize the ability to create user credential that the application will require. It's like a system admin, or system admin, sort of credential, or it's just automation permissions that we need to create the corresponding credentials. So the first thing to do is this, and then what we can do, if we do to apps, let's go to the client intent here, DB intent. So in the DB intent, it's pretty much the corresponding intent for everyone. On top of that, we have added, so with Authorize export mapper, we have just generated, remember, the network stack, right? So now we have here, let me show you, we have the extra component for every service. So for example, the player, we need select, insert, and update. So here is because I'm a good developer, I've done my due diligence. I know that, for example, here, my interrogation service just needs select. So again, right, it's just, if I go to interrogation service, I go there, I go into my code, I see list suspect, select, get interrogation question is select, and that's basically it. So in my code, I know I just need select. But again, remember, we can also do it via eBPF, and hopefully I don't have to introduce eBPF. It's super popular. Everyone is using it. So it just allows us to get more visibility on whatever is coming from the Linux kernel. So yeah, I just repeat this for every service. So now we can just apply this DB intent, which is, if I go back to the client intent, it's just going to kind of decorate the existing one, right? So let's apply this. So you can see some of them are configured, and the one from the init job, because of course the init job also needs to connect to the database. And now if I click refresh here, I should see a new integration. So now I see my database integration is there. And as a result, now I should see multiple things that happen. So now I should see new secrets, because again, as soon as I deploy the client intent, it should reconcile what's in the cluster. And so again, let's go to the game service. Now I've got the database section part no, no, actually, the game service doesn't need to connect to the database. I should know it, right? The game service is there, doesn't connect to the database. Let's move to the case service. Case service here. So it needs select insert. As soon as I push this, like the type database and the different operation, then I should see stuff happening in my cluster. So let's monitor the secret, right? So secret, now every service that needs to access the database has a corresponding secret. Let's say we're using the case secret. So case secret here, you have in the password username, which is obviously not encoded in base 64, not encrypted whatsoever. If you need to encrypt the secret, then it's another solution. It's not about Otterize. Otterize won't encrypt it, so you have to use something like Vault or something that will, or Trousseau or something that will encrypt the secrets in etcd and in the secret. So now if I do a secret here and I decode, I see decoded my username and the password. So I should see also, as a result, this secret, this credential should also exist in the database. So if I exec here, I'm just gonna, excuse me, sorry. If I just execute on my database pod, I just want to list the privilege from the schema and basically get the user, and their association to the permissions. So you should see here all the user for all the permissions for all the different tables. Right. So we have different tables, but remember, I didn't go by table. I went for the whole database. But if I want, I can specify all the tables. But yeah, basically it's here for every. We have generated just-in-time credentials for every service, right? And these credentials now, the only remaining part in my application, I need to use those credentials to make my application work, right? Because my application currently uh, is still using, actually I'm going to show you what it's using, but it's not definitely not using this credential. So that's the last part that remains under the developer's responsibilities. Use those credentials that we have generated. So again, these credentials are just in time, meaning that we can also rotate them. So in this instance, I didn't choose to rotate them because it's just a demo, but in production, you want to rotate them, every once in a while. And as a result, we can also automatically, as it rotates, we can restart the application, restart the container, accesses the application, which should not be a problem in Kubernetes because you have multiple container, you have replica sets. So we will honor, like how to restart the containers in the right order. If you have I don't know, stateful set. But yeah, normally you shouldn't see any downtime for sure because of the deployment object in Kubernetes. So the application itself. So let's check the deployment. So let's check. So the case service here. If we go into secret. Um, hmm. So currently, this is what we are using, right? So you can see here the application credential. The credentials to connect the database are injected as secret, and it's currently using DB secret, right? So it's not using the special short-lived credentials I've created. Is using the DB secret, which is the same as what Otterize is using, which is essentially the admin secret, right? Because I've been a bad developer and I was too lazy to create my own user, right? So now, again, we are using Argo CD. So the only thing I need to do is, I believe it is that application here. If I go to detail, change the target revision because I've got a revision that is actually changing this in my application. So if I go, that is Argo CD set, I believe, or app set revision to local, and this is the branch. And in that branch, I've got the oops. Let's do this. In that branch, I've got the right deployment with the right secret. So let's monitor this. It should reconcile. You can see that the containers have been redeployed by Argo City. So now if I jump into, let's say, the case service again, I should see now secret. So you can see, yeah, I'm using the case creds now, right? I'm not using the DB creds as a secret. So now we know that the application is using the right credential with the right permission. The only thing we need to do is make sure that the application is still working. So for this, sometime I have to restart something, but let's try. So again, let's use set a new game. Let's connect to the application with WSCat. Name. No, okay. So it's at least now we have the case that is working, and actually we can go into the logs, right? So in the logs, yeah, in the logs we don't have any error message, so everything is fine. So just we like just checking a few things, and then let's go back and locations and just examine, I don't know, parking lot again. Yeah, I mean basically the application is working, so we good. And next, the last part that we need to do is enforce the network policies. So we have all the client intents that are there, but we don't have any network policy. So our application is not secure. We have secured the database, but how about the network policies? So for this, I can just go back in my integration, which was ODA configure, turn enforcement on, and you can see it's basically just a flag in my helm chart, or I can just copy, paste this. It's just going to upgrade my chart and restart the containers, authorize containers at some point. Here you go. So let's just wait for the intent operator to restart. Running second container, and in a moment. So from the access graph, I shouldn't see any difference. It should still be green. But what we should see is new network. So you can see all those new network policies now. So now I won't go in detail because it's not the topic for today, but all those network policies have been created with the right, we have attached the right labels in a way that the application now is entirely secured. Right? Okay, I mean, that was pretty much it for the demo. I don't know if there is any questions so far.
Not so far. We don't have any questions yet. So
Good.
yeah, folks, if you have any questions, feel free to ask right now. Yeah.
So we can go back to uh, the slides. So yeah, it's basically shows you like some of the authorized capabilities. So we have insisting on the database. It's very important for developers to be able to develop without any friction. Opening Jira tickets. I was last week at AWS reInvent talking to a lot of developers, and you can't imagine the number of people who told me, yeah, it's true. We have to use like Terraform static templates for IAM roles and things like that, or Terraform templates for whatever you. So yeah, some static kind of process. Here, everything is kind of dynamic.
Hmm.
So we can also generate IAM roles in the cloud, and we can
Hmm.
also automate MTLS. We can do a lot of things. You can just, if you're interested, you can go to the doc, go to
Yeah.
the tutorials. So here, if you go to the SQL part, you will see a long tutorial on these other applications. What I've gone through today, you can do it as a
Hmm.
in a sandbox if you want. So you with a predefined cluster, you're going to install Otterize, work with the app, do the network segmentation, database segmentation. So you can go to
Hmm.
docsauthorize.com for different features. And if you
Yeah.
have any other questions, or if you're interested into testing it, you can join our
Hmm.
Slack community where
Yeah.
I'm monitoring basically all the time. So yeah, that's
Mm.
essentially it.
Great. So yeah, that's the QR we can you guys can scan right away, so you guys can
Yeah, there's a
contact.
QR code here and the link, which is just joinslack.authorize.com with the link as well.
Yeah, that would be great. So yeah, mm, I think that should be pretty much it for all of us, right? So yeah. Okay, so another aspect is like talking about the you were mentioning that it's open source, right? So like any way folks can contribute to
Yeah,
the project.
we have, you go on GitHub, authorize,
Mm-hmm.
on the it's called just on GitHub/authorize. We have all
Uh-huh.
our code that is there. So of course the code of the website is I mean of the cloud part is not there, but there's not much in it. We don't, you cannot configure really anything there from the cloud. But yeah, all the code for all the different operators, all the automation is open source. And actually we had a contribution for Linkerd integration. So today we
Mm-hmm.
support Linkerd thanks to a contribution from a member of the community. So
Mm-hmm.
yeah, we had done Istio in the past, so the person wanted to get the same thing with Linkerd. So yeah,
Uh-huh.
contribution are more than welcome. And something as questions. You can ask questions either on GitHub if you want, or if you notice any
Mm-hmm.
feedback. If you don't want to join the Slack channel for whatever reason,
Yeah.
yeah, probably join the Slack would
Yeah.
be easier to get like instant
Mm-hmm.
response
Yeah.
and answer. But
Yeah.
yeah, you can also open any issue on the our GitHub
Yeah.
repos.
Both works, right? So well, like developers, as developers we prefer GitHub issues, and obviously professionally we also have like maintain the Slack, right? So yeah,
Yeah, so both
both are the
are
good options.
feasible.
Yeah.
Yeah, and if you want to talk to me as well, you probably see me at all the KCDs in Europe. I'm trying to
Uh-huh.
get there as much as I can to make the
Yo, so the
community.
KubeCon is coming up so in the
Yeah,
maybe
I will
April or
be
May.
there. So if you're more
Yeah.
interested, also you can meet Authorize and the team. There will be all the devs probably in KubeCon in London as well. So we
Uh-huh.
definitely have a booth there. So yeah,
Yeah. Okay. So
just
yeah,
come
that
say
should
hi.
be awesome.
Yeah,
Yes, awesome. So yeah, folks. So I'm assuming we don't have any questions. So and if you have any questions, you have to like just join the Slack. That's the process, right? Or you can just ask questions in the GitHub issue. So yeah, thank you so much, Nick. I guess so. We can
yeah,
end our session, right?
yeah. No problem. Yeah, yeah. Thank you
Okay.
for having me today. It was great. Hopefully,
Yeah.
people had fun as much as I had. And
Yes, that was really awesome. Like
yeah,
talking about the clues, right? You knew the answer. That's why
yeah.
it took
I know. I know.
much less time. But talking about again the clues, uh, the guard I believe was much more suspicious, right? We could initially go to there, right? You
Yeah,
initially
yeah.
started with the
I
doctor.
mean, yeah, yeah. And the
That's awesome.
version 2 of the application, I've got a CSI, the crime scene unit that
Mm-hmm.
comes there. You can send clues for extra inspection. So you kind of
Oh.
enable new clues based on what you already have. But now I
Uh-huh.
only had one case in the database. Now everyone
Oh.
knows the answer. So I need to create more cases now.
Yeah, it would
And
be great. Like at least two
yeah.
to three cases or something, so that folks can try also, right?
Yeah, and maybe we
Uh,
can we can do something like, if you find like if you do the labs and you find the culprits, in that
uh-huh.
time we can organize some swag or something. We can work on
Oh,
something.
less time or something. But
Yeah,
then
yeah, we
again,
can
the
work
thing
on
is,
something.
uh, the answer is something like folks can know, like, okay, this is the answers for that. So let's
Yeah,
try
yeah,
with
with
this
a
clues and
link
so on.
to. But yeah, if people just connect with me on LinkedIn, I will also advertise. I'm publishing labs, fun labs and stuff like that, around
Mm-hmm.
authorized technologies. So if you want to
Uh-huh.
stay up to date, you can also connect with me on LinkedIn, and I,
Mm-hmm. Yeah.
always update there with new content. So yeah.
Yeah, awesome. So yeah, thank you so much, Nick, for being here, and that was awesome. Actually, learning about the intent one and also the quiz as well. Okay,
Cool.
so thank you so much, guy, Nick. Hope to see you soon.
Yeah, thank you. See you guys. Bye.
Okay, great. So thanks everyone for joining the latest episode of Cloud Native Live. So we enjoyed the interactions and thank you for joining us today. So if you have any questions, you know where to ask the questions. You can also add the questions in the comment sections, and obviously we share the Slack channel, so feel free to just join the Slack channel. Okay, so thank you so much, and see you again in